What could formaldehyde, vinegar, and glucose possibly have in common? Formaldehyde is a poison and will preserve biological specimens. Vinegar is a seasoning, and glucose is sweet and yummy. So what on earth could these have in common? So let's figure that out and maybe learn something along the ways about chemical formulas. Let's look at formaldehyde first. I want us to calculate a ratio of elements. Well, is this really a calculation? We're just looking at it. So we have 1 carbon, 2 hydrogens, 1 oxygen. This has a 1 to 2 to 1 ratio between carbon, hydrogen, and oxygen. Vinegar, we have 2 to 4 to 2 between the 3 elements, and glucose 6 to 12 to 6 between the 3 elements. Now let's simplify these ratios. Well, that's still going to be 1 to 2 to 1. For formaldehyde, for vinegar, we can take out a common factor of 2 out of these numbers. And we can get a simplified ratio of 1. 4 divided by 2 is going to be 2, and then 2 divided by 2 is 1. So we have the same ratio again. Glucose, hopefully you see a common factor of 6. That can be removed. 6 divided by 6 is 1. 12 divided by 6 is 2. 6 divided by 6 is 1. So all of these compounds, all 3 of these compounds, the deadly one, the seasoning, and the sweet one, all have the same ratio of elements. This ratio of elements is what we call an empirical formula. The empirical formula is the most simplified way of writing the original molecular formula. So we would write the empirical formula for formaldehyde. Well, it's the same. It would still be CH2O. The only time your empirical formula is the same as your molecular formula is if there's no way to reduce the numbers further. Okay, how about vinegar? We would write that as, sorry, I'm adjusting the screen here. CH2O again, C1H2O1, and glucose gets the same thing. So all 3 of these compounds have the same empirical formula. All right, if you like to study the meaning of words, the word empirical means from experiment. It means it has a basis in reality. Yet, these are definitely different molecules. They have very different chemical structures. So what type of experiment could that be? That is from an experiment called mass analysis, also known as elemental analysis. An elemental analysis is based off of mass percentages. So in an elemental analysis experiment, you have you load a little sample into like a tin foil or aluminum foil little cup, and they're tiny. You load a material in, you close it, you burn the daylights out of it, and then any carbon in your sample will turn to carbon dioxide, any hydrogen will be turned into water. Maybe there's a nitrogen component as well, reducing the nitrogen to nitrogen gas or something. And it counts the amount of material for each of those elements. And then oxygen comes through subtraction. Okay, you don't have to remember all of that, but it gives you a printout of what elements you have in your system. The whole deal we're getting at here is no matter what molecule you had going in, it's just spitting out pure elemental information because you have completely destroyed all the original bonds in your original compounds when you burn the daylights out of it, and you would get that same chemical formula empirically from that mass analysis, elemental analysis experiment. Okay. What I want to tell you though is, what is the most important chemical formula? Is it going to be the molecular formula, the true, real, actual chemical formula? You kind of already know the answer here. Or the elemental, or excuse me, the empirical formula? I'll answer my own rhetorical question. Okay, molecular formulas 99% of the time are more important. And for your typical intro chem student, that's usually the one they're going to end up caring about in everyday life. The reason why we have to learn an empirical formula, though, is that every now and then we'll have to do some work where we might actually just be more interested in the ratio of the elements than where it actually came from. An example of that would be maybe you work in metallurgy or something, and you don't really care about the mineral form so much as just the percents of different elements and metals in the material. I mean, you may not really care what the actual chemical formula is. If you were trying to decide on like an iron source and you had a mineral that gave you 25% iron versus 30% iron, you may not really care what its actual chemical formula is so much as caring about the yield of iron from that material. What I want you all to take away from this, though, is that the chemical formula represents the actual, or excuse me, the molecular formula represents the actual chemical formula. So here's formaldehyde: 1 carbon, 2 hydrogens, 1 oxygen. Acetic acid, vinegar, in reality, it's not the empirical formula. Again, the real reality is its original molecular formula. 2 carbons, 4 hydrogens, 2 oxygens. How about glucose? It depends on if it's dissolved in water or not, whether you have this cyclical structure versus this structure here. But you count up the carbons, you have 6. You count up the hydrogens, 12, and you count up the oxygens, 6. So again, the real chemical formula is the molecular formula. All right. The key concepts I want you to take away are this. The molecular formula is the true chemical formula for any molecule. And when we're talking about molecules, this is going to be 99% of the time. This is not a measured number. This is my estimate. But most of the time more important than the empirical formula. Whereas the empirical formula is the most simplified whole number ratio of elements in a compound. Please note that if we're talking about ionic compounds, almost all the time, those ionic compounds are going to have chemical formulas that are actually empirical formulas, because that's what you're supposed to do with ionic compounds. So some examples of that would be like sodium chloride, magnesium sulfate, sodium nitrate, iron 3 oxide, etc. Whereas for molecules, we're talking about like water, CO2, we had glucose earlier, things like that. There's other examples like arginine, buckyballs, Buckminster fullerene, tetraphosphorus, decoxide. We can go on. These are the real molecular formulas. So anywho, I hope this helps. Next video will be the calculation side of being able to calculate empirical and molecular formulas. Hope this helps. Have a wonderful day. Take care.